Welcome. This video is about CIE AS level Probability and Statistics 1 9709 Probability and Statistics Practice Paper 7. Khadijat noted the weights x grams of 30 chocolate buns. So n equals to 30. Her results are summarized as sigma x minus k whole square is 4022. So sigma x upon n minus k equals to sigma x minus k whole upon n. So this is sigma x minus n upon n is 30.5, 50.5. 50.5 minus k equals to 315 divided by 30. So 50.5 minus k equals to 10.5. So k value equals to 50.5 minus 30.5 minus 10.5, which is going to be 40. Now find the standard deviation. Standard deviation is going to be the formula sigma x minus k whole square upon n minus sigma x minus k upon n whole square. So which is going to be 4022 divided by 30 minus 10.5 whole square. So simplify that, you should be getting 23.817 square root, which is 4.88. Now coming to question number 2. Ashfaq throws two fair dice and notes the, nu- notes the numbers obtained. R is an even. The product of the two numbers is 12. So product of two numbers is going to be 12. So what is that? 2 6, 3 4, 4 3, 6 4, 6 2. So how many such options are there? Four options. So each option is going to be 1 upon 6 times 1 upon 6, which is 1 upon 36. This is also 1 upon 6 times 1 upon 6. So let me bring that one down. So for each one, it's going to be 1 upon 36. So for this is 1 upon 6 times 1 upon 6, which is 1 upon 36. For this one also, it's going to be 1 upon 6 times 1 upon 6, which is 1 upon 36. 1 upon 6 times 1 upon 6, which is 1 upon 36. 1 upon 6 times 1 upon 6, which is 1 upon 36. So totally, it's going to be 4 upon 36. Now, t is an even. One of the numbers is odd and the other number is even. So probability of t equals to probability of odd comma even or probability of even comma odd. So which is 1 upon, how many odds are there? 3 odds out of 6. 3 evens, 3 out of 6, or 3 out of 6 times 3 upon 6, which is 1 upon 4 plus 1 upon 4, which is going to be 1 upon 2. Now what is being asked? By finding the appropriate probabilities, determine whether R and T are independent or not. So probability of R intersection T. I am going to find probability of R intersection C, where one number is odd, another number is even, and the product has to be 12. So P 3, 4 or 4, 3. So this is 1 upon 6, 1 upon 6 plus 1 upon 6 times 1 upon 6, which is 2 upon 36, which is going to be 1 upon 18. Now, to be independent, probability of R intersection T should be equals to probability of R times probability of T. So 1 upon 18 is equal to, this is a probability of R is 1 upon 9 and probability of T is 1 upon 2. 1 upon 9 times 1 upon 2. Are they equal? Yes, they are equal. So therefore, they are independent. Independent. Question number 3. The probability in a probability distribution, the random variable x takes the values of x such that it is kx square. It's going to be kx square, where k is a constant and x takes the values -2, -1, 2, 4. Now what is being asked over there? Show that p of -2 equals to, has the same value of p of x equals to 2. So X is -2, -1, 2, and 4. So probability of capital X equals to small x. So this is minus k times -2 whole square, k times -1 whole square, k times 2 square, and k times 4 square. So that's going to be the value. It is k times 4 square. So now what is being asked us to prove it out? Probability of x equals to -2 will be k times -2 whole square, which is 4k. Probability of x equals to 2, which is k times 2 square, which is also equals to 4k. Therefore, both are equal. Now, I am going to draw the probability distribution table for that. It becomes -2, -1, 2, and 4. -2, -1, 2, and 4. So x, probability of capital X equals to small x. So it becomes 4k, k, 4k, and 16k. Find the value of k. We know that sum of all probabilities is equals to 1. 4k plus k plus 4k plus 16k equals to 1. So 25k equals to 1. K equals to 1 upon 25. 1 upon 25. Now find the expected value of x. Expected value of x equals to 1 times -1 times -2 times. So starting with -2, -2 times 4k plus -1 times k plus 2 times 4k plus 4 times 16k. So it's going to be 63k. But k value is nothing but what? 1 upon 25. So 63 upon 25, which is 2.52. Coming to question number 4. A random variable x is following the normal distribution n equal to mu comma sigma square. Then what is being asked over there? Mu equals to 1.5 sigma. Then a random variable x is chosen. Find the probability that x is greater than 0. So we have to prove that x is greater than 0. For that, what am I going to do? Probability of x greater than 0. So probability of z greater than 0 minus mu by sigma. But mu is 1.5 sigma. So probability of z greater than minus 1.5 sigma divided by sigma. Sigma sigma gets cancelled. So what do I get from there? Probability of z greater than negative 1.5. So 1 minus probability of z less than negative 1.5. So which is 1 minus probability of z less than 1.5. So 1 minus 1 plus probability of z less than 1.5. Now check from the table, it's going to be 0.933. The life of a particular type of torch battery is normally distributed with a mean 120, mean equals to 120, standard deviation equals to S. It is known that 87.5% of these batteries last longer than 70 hours. Probability of x greater than 70 equals to 87.5 divided by 100. So probability of x less than 70 equals to remaining 12.5%. So probability of z less than 70 minus mu 120 by sigma. Sigma is S equals to 0.125. Now 0.125 is not there in the table. So subtract from 1. So 0.875. So swap this one. Probability of z less than 120 minus 70 by S. So this becomes probability of z less than 50 by S equals to 0.875. Now check from the table. It's going to be 50 by S equals to 1.151. So S equals to 50 divided by 1.151, which is going to be 43.4. That's going to be the answer for part B. Now come to question number 5. Hebe attempts a crossword puzzle every day. So The number of puzzles she completes in a week, 7 days, is denoted by X. State two conditions that are required for binomial distribution. For binomial distribution, what are the conditions? The first condition is it should have constant probability. Probability should be constant. And second condition is there should be independent trials. Independent trials. On an average, Hebe completes 7 out of 10 puzzles. Use binomial distribution to find the probability and completes at least 5 puzzles. At least 5 puzzles means 5 plus 6, then plus 7. Then 5 puzzles. So what is going to be done? 7C5. Success probability is nothing but what? 0.7. Probability of success is 0.7. Probability of failure is 0.3. 0.7 whole to the power of 5. 0.3 whole to the power of 2. 7C6, 0.7 whole to the power of 6, 0.7 whole to the power of 1. Then 7C7, 0.7 whole to the power of 7, 0.3 whole to the power of 0. Simplify that, you should be getting 0.647. Use binomial distribution to the find probability that over next 10 weeks, Hebe completes 4 or fewer puzzles in exactly 3 out of 10 days. 3 out of 10 weeks. Exactly completes 4 or 4 or fewer means probability of x equals to 0 plus probability of, let me write there, probability of x equals to 0 plus probability of x equals to 1 or probability of x equals to 2 or probability of x equals to 3 or probability of x equals to 4 or probability of x equals to 4. So this entire thing, and exactly out of 3 out of 10 weeks. So what am I going to do that one? Instead of doing all this, 4 or fewer puzzles. So at least 5. So this all I have to add it out. Instead of adding all this, what I can do it out is, we know that from the previous one, C completes at least 5 puzzles, 5, 6, 7. 5, 6, 7 has been already been added. So 1 minus probability of x equals to 5 plus probability of x equals to 6 plus probability of x equals to 7 should be the best way. So which is going to be nothing but what? 1 minus, this answer was 0.647. 0.6471, which is 0.3529. This is going to be my new probability of success. So P equals to 0.3529. So failure will be equals to 1 minus 0.3529, which is going to be 0.6471. Now 3 out of 10 weeks, exactly 3 out of 10 weeks. So 10C3, 0.3529 whole to the power of 3, 0.6471 whole to the power of 7. Simplify that to 0.251. That's going to be the answer. Now question number 6. Coming to question number 6, a village hall has seats 40 people consisting of 8 rows and 5 seats in each row. 8 rows and 5 seats in each row. So we have to arrange them in a proper order. Mary, Ahmed, Wayne, Elsie, and John are the first to arrive in the village hall, and no seats are taken as they arrive. So, how many possible arrangements are there for these 5 people, assuming there are no restrictions? So, there are 40, 40p, 5. So, which is going to be nothing but what? 78, 960, 960. How many possible arrangements are there for Mary, Ahmed, Wayne, Elsie, and John If Mary and Ahmed sit together in the front row and other three sit together in one of the other one of the other rows. So how many rows are there? 8 rows are there and 5 seats in this. 1, 2, 3, 4, 5. So 8 rows. So let's draw so that easy to understand. 8 rows. I am drawing 8 rows. 1, 2, 3, 4, 5. This is the sixth one. This is the seventh one. And this is the eighth one. Now WEJ, what is the thing? The other three sit together in one of the rows. So they do not sit in the front row. So WEJ, they sit in another rows. Then here other two people. So they are sitting in another rows. So this can be done in how many ways? 3 factorial ways. So 3 factorial times 3 times 3. 3 factorial times 3 is going to be the ways, which is nothing but what? 18 ways. And how many such rows are there? 7 such rows are there. So 18 times 7, which is going to be 126 ways. For the other three people, it's going to be 103 ways. So what is that? WEJ will be sitting as 1 unit and another 2 people are there. So therefore 3 units. So 3 factorial ways. 3 units can be done in 3 factorial ways. Then the WEJ can be happened in WEJ and WEJ. So it can happen in 3 ways. This is one way, this is second way, and this is third way. That's why this is 3 ways. So total is going to be 3 factorial times 3 ways, which is 18 ways. But again, there are 7 rows for that. So 18 times 7 is nothing but how much? 126. Now coming to the front row. In the front row, what is it? M and A sit together in the front row. So M and A sit in the front row. So we are talking about the front row. For the front row, MA sit together and other 3 people. So MA and other 2 people. 2 people, MA and a single. 3 people and MA. So how many ways it can be done in? 4 ways. And M and A can among themselves in what? 2 factorial ways. So what is that? Is going to be 8 ways. So the final answer is 126. So because I have to arrange the first row and other rows. So first row is nothing but what? 8 and 126, which is going to be 1008. Now coming to question number 7. Then that is 6 part 2. Now coming to question number 7. The following histogram represent the lengths of the worms in a garden. The lengths of the worms in a garden. Calculate the frequencies represented by the each of the 4 histograms. He's asking us to calculate the frequencies. So what am I going to do? I am going to calculate the heights first of all. When I'm going to calculate the heights will and the area. So will be giving me the total number of worms. So first of all, for that, I am going to take the heights. So how do I hide the width? What is the width of the first one? 5 is going to be the width of the first one. We need to calculate the height of the second one. What is the height of the second one? The height of that particular this is 4, and how many parts are there? 10 parts, so 0.4. So each one has to be 0.4. Each line has to be 0.4. 0.4, 0.8, 1.2, 1.6, and this is 2. So it's going to be 2 times 5. which is 2 times 5, which is going to be 10. Then next, this gap is again 5, and over here it is 8. 5 times 8, which is 40. Now for this gap is 10 times, and this is nothing but what, 12. 10 times 12, which is 120. 10 times 12, which is 120. And for this one, this gap is 5, and this height is going to be 6. So 5 times 6, which is going to be 30. Then on the grid on the next page, draw the cumulative frequency graph to represent the lengths of the worms in the garden. So we have to draw the cumulative frequency graph. So what am I going to do? We can see that length and cumulative frequency. Length less than 5. How many are there? 10 are there. Less than 10. So less than 10, how much do I get it out? 40 plus 10, 50. Then less than 20. Less than 20 will be 50 plus 120, which is going to be 170, and less than 25. So all the remaining totally 200. So I'm going to draw the frequency, cumulative frequency graph for this. This is the x-axis and this is the y-axis. Now cumulative frequency on y and length in cm. So this is going to be 5. Okay, I can do like this. 5, 10, 15, 20, 25. If I do like this, it becomes too short for that. So I will be taking double gap. This is 5, this is 10, this is 15, this is 20, this is 25. And the distance is going to be 50. Okay, over here 50, over here it is 100, and over here 150, and over here 200. Now when it is 0, it is 0. Then when it is 5, it is 10. So the gap is 50, and there are 10 parts, so each part is 5. So when it is 10, so over here, then for 10 it is 50. Then for 20 it is 170, 170, and for 25 it is 200. So 150 was this, 60 and 70. And for 25 it is 200. 200. Then draw the cumulative frequency graph for that. It looks approximately like this. Use your graph to estimate the median and the interquartile range for this. So median is nothing but what? 2. For median, 200 divided by 2, which is going to be the 100. So from 100, draw the line, hit the graph, and drop it down. So this is approximately 12, 13, 14, 14.5 or 14.2. 14.2 is going to be the Q2. Now for Q1, which is 200 divided by 4, which is 50th observation. So from 50, draw the line, hit the graph, and drop it down, which was already 10. So Q1 is going to be 10, and Q2 is going to be 14.2. Finally, Q3 is 200 times 3 upon 4, which is nothing but 150. So from 150, draw the line, hit the graph, and drop it down. So this is going to be something around 18.5. So 18.5 equals to Q3. So Q3 minus Q1 is going to be 18.5 minus 14 minus 10, which is going to be 8.5 is IQR. Then the last part, calculate the estimate mean length of the one. So mean means nothing but what? Sigma fx upon sigma f. X is going to be the midpoint. So we have to calculate the midpoints. Midpoints are nothing but what? X. So go back to the table where we have done. This one was 0 to 10. Then this one was 0 to 5. The first one was 0 to 5. Then this one was 5 to 10. This is 10 to 20. And this is 20 to 25. So what's going to be the midpoints? Midpoints are x. 0 plus 5 by 2, which is 2.5. 5 plus 10 by 2, which is 7.5. 10 plus 20 by 2, which is 15. And 20 plus 25 by 2, which is 22.5. So it's going to be 2.5 times 10 plus 7.5 times 40 plus 15 times 120 plus 22.5 times 30 divided by 120, 200. So this is going to be 14. So the estimated mean is going to be 14. So that completes the paper. See you in the next paper. Bye.